A NASA scientist once looked at the maths for warp drive and thought the trick might be to just change the geometry, change the shape, change the universe. These are the 10 challenges to building a warp drive, and this is number 5, NASA's geometry trick. Harold "Sonny" White of NASA's EagleWorks lab presented a modification of the Alcubierre metric at the 2012 100-Year Starship Symposium. Now, he didn't claim to have cracked warp drive outright, but he did propose that altering the bubble's geometry could drastically reduce the energy needs. The stress energy tensor depends strongly on the curvature distribution. So geometry changes the required energy density. Basically, the shape of the warp bubble affects how much energy you need. So Alcubierre had assumed a spherical bubble in his original paper, and White asked, well, what if you make it toroidal instead, which is kind of like a donut rather than a ball? By changing the geometry, making the bubble thicker in some places and thinner in others, you could distribute the space-time curvature more efficiently. So for a 10-meter bubble, you would go from Jupiter's mass down to Voyager's mass. Not that Voyager, that Voyager. That's about 700 kilograms. Now, NASA announced the results. Headlines everywhere. NASA was developing a warp drive. And for about 48 hours, everyone was really excited. And unfortunately, people do still bring this up whenever I talk about energy requirements. The thing is, pretty quickly, people checked the maths. The problem was that White had made some really optimistic assumptions. Basically, he oversimplified. When you properly account for maintaining the bubble's stability and achieving the necessary curvature, the energy savings disappear. The geometry helps, but it's not nearly enough. You still need astronomical energy. You're just arranging it differently. Now, another thing is that White's credibility also took a bit of a hit because around this same time, he'd been promoting the EM drive, which was supposed to be a device that supposedly produced thrust without propellant, violating conservation of momentum. Now, it didn't work. The results turned out to be just a measurement error. But ultimately, NASA removed the EagleWorks warp pages and papers from its website back in 2019, although you can still get archived copies from the Wayback Machine if you're interested. So we still need huge amounts of energy for warp. But even if you could get enough energy, you can't get the right type of energy. But that's for the next episode. Stay nerdy.